Let me check if I pressed record everywhere. Let me turn this off.
People are calling.
Dang it. Recording, yes. How do I start? What if I say green button?
No way, dude.
Hi everyone. Welcome again for another episode of Webwise Research. In this video, we are going to be talking about semiconductors, and I have with me a friend of mine, Awse. Awse has been a very close friend of mine who has helped me learn about the semiconductor industry a lot. The conversation that we are going to have today is a conversation that we've had a lot of times between us. That is how I have learned a lot about semiconductors. Awse works for Applied Materials. I will let him introduce himself as to what his role is at the company. Awse.
Yeah, thanks for having me. I've been working in Applied Materials for about 8 years. I'm specifically in the process engineering realm. I'm a process engineering manager working in silicon epitaxy. That means on a day-to-day, I'm basically designing films, executing films and growing films for customers for their integration modules, where we end up packaging that plus many other steps in the process for the transistor and for the SoC for our tertiary customers to be able to sell products for you guys on a day-to-day, whether it's phone, laptop, servers, automotive, and military, all in all.
IoT also.
IoT, of course. The entire spectrum Applied covers pretty much all equipment manufacturing for any type of chip, either analog, logic, memory, IGBT, CIS image sensor, wafer makers. We cover the entire process end to end.
Cool. So one of the main things that I want to achieve out of this video today is to get a sense of like a broad understanding of what the semiconductor industry is. So trying to understand the fact that Nvidia doesn't make its own chips, TSMC does, and what is the role that a company like ASML plays in that, and what role does Lam Research and AMAT plays, things like that. So we just want to get a broad understanding of that. So we have this graph that you throw up on the screen, and also if you could walk us through this, I would really appreciate it.
Yeah, absolutely. So I totally understand why a lot of people in the world, recently semiconductor has become like an area of interest, but in the past it wasn't a quote-unquote sexy industry, so a lot of people didn't really understand the fundamentals. But there's a lot of players in the game. It's a really complicated industry, many players doing different things. Some try to do everything at the same time. So the easy way to think about it is a value chain or a sequential chain. So essentially it starts from raw materials, equipment manufacturers, designers, software designers, chip test equipment, and finally packaging and production. And within the packaging and production, you have foundry base and fabrication facilities. And it's a very, very hard industry to master. So there are a lot of players doing great things. I work in the equipment manufacturing side, but to be able to sell your equipment, you have to also demonstrate your equipment, which comes with a lot of process engineering requirements, which end-to-end are the basis of what manufactures the CPUs, the memory chips, the analog, any type of IC essentially, or an integrated circuit. So from the equipment side, I like to start there because fundamentally that's where the entire semiconductor industry really got born. Applied actually started off by trying to be a chemistry company. And while we were trying to demonstrate our chemistry efficacy, we found out people were more interested in the equipment we used to demonstrate our chemistry, and that's where the story started. Applied is pretty much the broadest portfolio in the equipment manufacturing game, but by far not the only one. We have a lot of competitors in the game. Amazing things are happening with these companies like ASML, of course, the lithography. They're pretty much the focal point because they've become an industry monopoly over the years. Applied likes to play along every single facet of the chip manufacturing. We are not in lithography at the level of ASML, of course, but we tend to dominate in other sectors, and we have competition, of course, in other sectors that are way stronger than us, like Lam Research, like Nikon, Tel, Hitachi, ASM, and each of them excel in a different product line. My product line is silicon epitaxy, the base of the transistor and the base of silicon wafers. So as the demand for products are getting more and more intense, silicon epitaxy went from a single step to over 17 or 20 something steps. So with that in mind, most of the processes start with us, with my actual business unit. We develop the wafers get manufactured by raw material companies like Sumco, SCH, Siltronic. Those companies dominate the industry. They supply all wafers to us, to our vendors, to our customers. People like TSMC, Global Foundries, all use the same raw materials from these companies. Each of these companies have varying product lines where they basically have high purity, low purity, medium purity. That's based on, is it a product wafer or is it a testing wafer, an R&D wafer? And that's where it starts. And then those wafers come to us where we prove ground about our equipment. Our equipment is supposed to pass specific specifications that are required by our customers, the TSMCs of the world, the UMCs of the world, Intel, Samsung, Texas Instruments, etc. Our portfolio is very broad.
And I just want to like dumb this down a little
Yeah.
bit for myself, honestly.
Absolutely.
What is that you guys make and send to TSMC? Like, what is the retail your equipment? What is that?
Yeah, very good question. I think the equipment, I wish more people can see it. You can search it online and to see how the fabs look like. But essentially, if you look at a standard video about what a fabrication facility is like, you see these massive machines. They generally would cover basically bigger than a one-bedroom apartment. And an EUV tool would be like absolutely double that.
School
And
bus, I've heard.
yeah, with really, really big tools. And the display side, it's the size of a football. The display tools actually cover the size of a football field. Humans can actually walk inside of the tool. So each of them are amazing feats of engineering. Honestly, I wish more people can actually understand the level of engineering that goes into the tooling. So what we do is we sell the equipment. The equipment entails robotics, lasers, high temperature reactors, CVD, PVD. CVD is chemical vapor deposition, PVD is physical vapor deposition, ALD is atomic layer deposition, and so on and so forth. There's a lot of acronyms in the industry, so I totally understand the confusion.
Let me ask you another question.
Yeah.
How do, like, say, Lam Research, AMAT, and say ASML also for that matter, what are the commonalities between these companies and what's different between these? Like, what I want to understand is, like, does one chip go through all three different companies' machines, or are they completely different processes in that case?
Absolutely, no, they do. They do. So ASML back in the day basically went on a whim and decided to put all their eggs in the basket of the EUV or the lithography. It was DUV, deep UV, or extreme ultraviolet. Those are different technologies, but they went after the lithography. Lithography is essentially the blueprint of the chip. You're actually scanning, etching, and making the highways that make the circuitry on the processor. Our tools are either deposition, polishing, etc. They're steps within the 950 something step process for a CPU, for instance. Many, many steps. And that will entail every single equipment vendor you will see in the value chain on the chart. Every single person, every single player in this game will have a step that they play into this. So a TSMC would buy all of the equipment you will see in the value chain. Each of them excel in a specific area. AMAT has a broad portfolio, but by no means in every sector are we dominant. We want to be, but that's not the case. ASML dominate the lithography. Applied is very good at deposition, very good at back-end copper where they lay the circuit interconnects. TEL is very good at cleaning the wafer between different stages to prevent defectivity. Lam Research is excellent at dielectric, which is very critical at maintaining where we want to grow film, where we don't want to grow film, how we build electrical signal, where we don't want to build electrical signal. So the base of semiconductor is essentially a material that's neither an insulator or a conductor. By adding material into the silicon, we make it electric conductor. The dielectric part is essentially a non-conductive part that creates boundaries around those circuits to make sure that we can tap in, tap out, and make sure the signal goes in so the computer can read that 0 and 1, the binary. It's of course far more I've simplified this far more than it needs to be. But in the grand scheme of things, the equipment people will definitely sell the equipment to the foundries and the fabrication facilities. Those are the people that spend and buy the capex and very expensive tooling. Tooling could range from a few $100,000
Yeah, so
to a few $100 million.
let's talk about foundries versus fabrication. What's the difference between the two? What are those things?
Absolutely. So back in the 90s,
And
everyone was a
within
fab.
that, within that also explain where Nvidia and AMD fall into this ecosystem.
Oh yeah, of course. So I think if you think about the big guys, when you're looking at the Nvidias of the world, the Broadcom, the Qualcomm. They're fabless designers. So essentially, they're the architects of the entire operation. They're the people that design what we call a reticle. Essentially, they design it all in CAD, similar like you design any hardware. They design the circuitry, the layout, the technology and IP behind what the device needs to be doing. And then they send that blueprint.
Because you're talking about it, what do they design that on? When we talk about that, at what point?
Oh, there's arrays of softwares. I'm not on the software side too much, but there's a lot of design software. Synopsys is a very big player in the game. There is simulation software where essentially you can design your full stack, model it, and test it virtually, and be able to at least infer what your design needs to be. But those guys are essentially the customers. They go and say, hey, I want you to go make me this to perform at this level. And then the TSMCs of the world and the applied materials of the world will have to co-work together between the machinery and the process engineering side, or the chemical engineering and materials engineering side, to make those specifications happen.
To get that yield, is that what
Exactly.
they talk about when they
Yield, process performance, there's a lot of metrics. It's too long to cover, but realistically, it's essentially the performance of the end device. Either a CPU, a GPU, a memory device. It's the speed of the memory, the amount of the memory, the speed of the processor, how many processors, the amount of graphical interfaces that they can generate, process, and actually deploy is also part of that.
I'll piggyback. You said they designed it on CAD. Do they actually do it in CAD, like Autodesk CAD?
Similar to it, not
Okay.
exactly like
Okay.
it. Electrical type CAD.
Are those public companies? Do you know the names of those companies?
I can give you later. There's a slew of them. We tend to not interface with them because we're a manufacturing company. We don't actually make that piece of software, but I'll happily share them with you for the users.
So yeah, let's go back to the design part.
Yeah, let me carry you through the post-fabless design. So they're the guys demanding the product, and then we have to go figure out how to make it. TSMC was the innovator of the foundry. Back when Intel began the fabrication facilities, or what we call fabs, essentially they're a design house and a fabrication facility. So they're all in one, a vertical chain.
NVDA and TSMC in one.
Essentially. But Intel was heavily focused on CPUs and integrated GPUs. Nvidia started its journey strictly focusing on gaming, and that's how they started their humble beginnings. But if we go back
quickly
to
explain the difference between that integrated CPUs, integrated circuits and CPUs and all that.
yeah, so central processing unit, or a CPU, is essentially the brain of the operation. They're the ones conducting all the operations that a computer needs to execute a simple task, from opening a window, opening an application, churning a mathematical equation. Any type of grunt work is driven by a CPU. Over time, we figured out that when Nvidia invented the first GPU, it was a simple enhancement to the game where it can handle the graphics part and leave the CPU deburdened for calculations behind the scenes. Over time, the GPU evolved to be able to handle a lot more parallel tasks than a CPU. There's a beautiful video where they show the difference between a GPU and a CPU. A CPU does serial calculations per core, but if you have more cores, you can do more calculations. GPUs can do parallel calculations all at once, and that's why they've become a powerhouse. But you cannot have a GPU without a CPU and vice versa in modern computing. But let's step back to the fabrication, because I think that's where a lot of people disconnect and lose the focus around that, because it's very hard to understand. Intel started all of this adventure. Actually, many other companies began during the Silicon Valley boom, but Intel was the big ticket item. They were a designer, a fabricator, and a materials company. They understood it very well. Over time, the cost of such operation became very, very intense. TSMC came online and understood the difficulty of this and how difficult it is to master the manufacturing piece. And they went on a whim and said, no, we're going to be basically fabless. We do not design, we only fabricate. And that's why they don't own any of the difficult design IP. They don't own any of the hard execution tasks. They own the expensive tasks, buying the tooling and fabricating the material on demand based on a customer specification. So Nvidia would run over to TSMC, say, hey, I want you to make this. And TSMC would go figure it out with us, with Lam, with ASML on how to build this very complicated highway with Synopsys. But primarily, most of the difficult, hard work happens physically on the tooling, materials, and the foundry side. Because a lot of people think foundry or fabrication facilities are, okay, I just upload this drawing and things happen. Totally far away from the truth. it takes years of multiple hundreds of people to develop such complicated processors that are in our phone that we take for granted. Um, Many projects I've been on have taken multi-year projects, and they're not even the bleeding edge. The bleeding edge would take anywhere between 5 to 10 years to perfect, and that's just on the R&D phase. That's not even on the manufacturing phase. So when you hear, oh, TSMC is working on the next generation, or the 2 nanometer, or the 3 nanometer, than this current A chip that's coming out of Apple, this technology has been in R&D for over 10 years, and it's so difficult to find the efficiency, the manufacturability, getting to the consumption cost, the material cost, and making it manufacturable at volume.
Like I keep telling you, like this is the cutting edge
It is the cutting
of
edge.
the cutting edge. Like there, I don't think it gets more cutting edge. You talk
Yeah.
about space, you talk about bioscience, like whatever you want to talk about. This is it. This is what it comes down to.
We're always attached to those industries. We
Which is
just
why
didn't
we-
get the recognition in the past. Now everyone seems to be interested, and it's great because that's what we need. We need more people to actually say, hey, I can actually influence this industry. Let me go in with my degree, go study, new students. And I really like that because this industry is super exciting. It needs creativity, it needs fresh minds, and we need to reinvent it. And that's what we're doing right now. And I think a lot of companies are doing that too.
Okay.
And yeah.
Let's come back to the chart. So we
Yep.
saw equipment, we saw a little bit of like a design, fabrication, fabless design.
Yep.
Do you want to talk about the rest of it?
Yeah, absolutely. So we covered the equipment side and then the fabless design side. So fabless design side, you have your Apples, your Nvidia, your Broadcom, your Qualcomm. These are interchangeable too. Apple also contracts specific.
Even Google, right? Like,
Exactly. Even Google is part of this. Google is new to the game, so this chart's maybe not up to date. But again, Google still uses older technology from TSMC. So I think Google will grow their Google Silicon, no doubt about that. These are the older players in the game. The leaders in the market are TSMC because they've mastered efficiency. I think if you throw a lot of money at the problem, you can still solve the same problem. But the IP behind it and the efficiency of how to deploy it is how they excel.
So are you saying that global foundries can also manufacture 3 nanometer chip, cost not being a concern?
They have the capability, but I think the IP still lies in terms of improvement to TSMC. They've
Yeah, so
actually improved and done better. The technology itself, this is very deep, right? But like when we start talking about architecture, the architecture differences are there, but then also how you execute these steps and the learnings of which comes first and which is better to come first, and how do you optimize the fab, how much the wafer moves around the fab, and the cost of it. Those all big plays. It's impossible for me to say because these are all IP within their own company. But Global Foundries has high volume manufacture all the way down to 14.7. They can go. But I think it's a cost game. This business is very expensive. And TSMC has been the unicorn in terms of figuring out how to make it work. And I think that's why we've been hampered in seeing chips coming out from the US market, because the US market is predominantly very different in terms of capital expenditure. Intel and the employment and how you spend on labor and costs is very different than the Taiwanese market, the Chinese market, the Korean market. Very different. That's why when you mentioned the Arizona fab, you are right about the fact that it's going to be hard, and how the chairman said it's about the people. Because at the end of the game, you can hire smart people here. We have extremely intelligent people, but you have to pay them very high wage, and there's a lot of expectation around the work culture. And yes, those are bridges that need to be crossed, and I think there needs to be a balance. And over time, I think AI will help alleviate that problem. Because instead of sleeping in the fab, we're going to have coworkers, co-pilots that will work with us. The tools will get smarter, the software will get smarter, the manufacturing will get smarter, the efficiency, the environmental aspect will get better. I think the gap will slowly come down, but not anytime soon, because right now we're still in an IP hoarding game. And that's why in a lot of the cases, I can't even go about the IP too much on a public forum, but each player has a contribution. Like a lot of people wouldn't even know about the company called Infineon. Infineon is a brilliant company. It's a German company that absolutely is amazing. They do power device manufacturing. I cannot say great things about this company. Great work culture, great performance, but they have carved their own niche. They work on power device. Power device is its own industry. You don't even think about power delivery. A toaster has a power delivery. Your TV has power delivery.
Everything.
Electric car has power delivery. But it's how you deliver the power, how you absorb the incoming power coming out of your outlet. 110, 240, 480, 408. All of those have a place in the game. The only people that get really highlighted are because they're customers of Apple, customers of Samsung, customers of Qualcomm. But the bottom tertiary chain, they're feeding the industry. If you go to Chipworks and pay, of course, for their membership, you can see they open up the iPhone, they open up the Samsung phones, the PCs, the tablets, and they show you how many components live inside of a PC. You'll be astonished. You'll think that, oh, TSMC manufactures everything. No, not at all.
Not at all.
The ST has 3-4 chips.
Yeah.
Bosch.
I usually try to think about like, where's the margin.
Yeah.
So like the reason why I would go after Nvidia, AMD, or TSMC. TSMC goes like relatively like less margin, but like as a foundry, I think margin is quite high.
Yeah, of course.
So from that perspective. So also like we have this another value chain chart which like if quickly want to go through this, make sure that we didn't miss anything, or just take at the same thing in a different way.
Yeah, it's
probably
definitely
not
a
spend
different
much time,
take.
but maybe just a quick 5-minute thing.
Yeah, it's a different take. It's just showing you stuff organized differently. So you have your design, your manufacturing, and your chip side. Chip side is basically the people that are buying the equipment and want to sell it to you as a
This is what I was
consumer.
talking about, the logic.
Yeah, the Apple, the Intel, the AMD, on the GPU side, Nvidia, AMD. Exactly. So
And that chip that I was talking about, what goes in a toaster is an analog chip, right? That is what it is, right?
you have analog, you have some logic, you can have multiple. If you open a toaster, you'll find a few ICs there.
But you could not have a GPU unless it's
No.
an AI toaster. It's coming.
Yeah, it could be, but at that point, it's probably still an
there's one on
integrated
I'm sure
graphics.
there's one on Amazon right now.
I think LG has a crazy toaster. It's like
Yeah,
$400 or something.
Yeah.
But on the design side, you break them down into the integrated device manufacturers or IDMs, and then you have your analog devices, Texas Instruments, Intel, Samsung, Micron, SK Hynix. Design software is EDA, Synopsys, Cadence, ARM, which is a big company now. Everyone's trying to switch to ARM. It is one of my
We
favorites.
will talk about that next.
Yeah, absolutely. And then your fabless designers, your Marvels, Broadcoms, MediaTek. MediaTek feeds a lot of the Asia market, a lot cheaper, easier manufacturer because of labor. Apple, Nvidia, and AMD. Those feed the manufacturing with what they need to execute their job and design their equipment. And then, of course, you have multiple players share the space. And TSMC is a fab. It's also a packaging side, and it also sells to Apple and AMD, etc. And then Applied, for instance, is in deposition tools, ion implanters. We bought Varian a long time ago. We almost struck a deal with TEL back in the day, but it got shut down for antitrust because it's a big deal. They dominate the coaters, the cleaners, etc. Shinetsu make the wafers, and so on and so forth. The industry is so big, you can go into granularity as much as you want. But on a high level, this chart should help, hopefully, the viewers really understand the depth of this market. That's the main game here.
And I just want to quickly take more to ASICs. So all these companies that are trying to build their own AI chips, this is what ASICs is. So Amazon, Google, Microsoft. I just want a quick call out for that.
Yeah, absolutely. They have a long road ahead. A lot of them are going to be utilizing existing technology within the foundry space because TSMC will definitely be there to go to. They'll just open it for a marketing play and they'll say, hey, I'm designing my own chip. But if you look at the Google processors and tensors, those are old TSMC known flows. So TSMC already has the flow. They're just repackaging it in the Google name. Change a bit of the design, of course. They created the design, but it's not groundbreaking. It's just shuffling steps around and generating that. I think Apple is more on the forefront of design, using ARM's architecture to generate the chips that they've been pioneering for a while.
So that's a good segue. Let's talk about ARM and x86. And just high level, can you talk to us about like what these are and why ARM is such a big deal?
Yeah, on a high level, we're gonna say x86 is really Intel's beautiful play into the industry. They invented this chip that is extremely intricate and complicated, and the flow is unbelievably hard. Probably why right now Intel is having a tough time is because when you innovate so much on something, it's very hard to go back and throw it all in the trash and say, no, I'm gonna dump to ARM. And that's where Apple really didn't have anything to lose at the time. They were looking for gains on software and vertically integrating their chain. And ARM has been there for a very long time, but nobody took them seriously. They designed protocols and layouts for chips that are fundamentally simpler to be able to work with the software in a way where you don't have to tax the CPU, tax the system on chip or the SoC, and draw so much power. So Apple took a very big leap of faith and went the ARM route.
And is it accurate that it was built for mobile, built for the
Yes.
moving world?
Absolutely.
That is why it consumes less power because it's built with that intention.
I think over time they had to lean into that department, but I think ARM was a small British company in Cambridge. They had the forefront and foresight to think about how the technology will be, and they were absolutely right. I really wish them well in terms of figuring out the financials because I really like what they do, and I think the world will move on that architecture.
Yeah, actually, so every laptop in the world, every phone is pretty much already on ARM, but every laptop in the world is, in the future will move to ARM.
And Microsoft is fully sending.
Absolutely. Apple realized that, oh, you know what? I have a phone. It uses such less power,
Yeah.
but I can actually build a laptop using the same technology.
Exactly.
And that is when they changed the game.
Because
on
they
that.
had the absolute luxury back when they decided the OS needs to be separate from Windows. And that was a brilliant move. I don't even think they thought about that even then. But now it fell right into their hands because the compute power went up and software efficiency went up. So when you begin working with ARM, you realize, hey, I can do this because I contain the software, I contain the apps. I
That
can
is why-
force the manufacturers and app developers to work in my ecosystem. But Microsoft and, let's say, the Android world had to move in that department very aggressively because they have a very big ocean to work with, all these different manufacturers, all these different suppliers, different software suites, app suites. To getting them online is very hard, but they did an excellent job with emulation. Emulation is taking an x86 type application and emulating it on ARM. And it used to have very bad latency. Now it's really good. You look at the Snapdragon X80 Elite chips made by Qualcomm, they're bloody excellent. They're doing a great job. And I really see the future being everyone on ARM, and competition is going to get really, really, really spicy. And you can already see the performance of these Qualcomm chips. It's actually in some cases beating Apple's own chips. And that's what I like to see. The best thing for us is more competition in this space. I don't want to see dominance by Apple and prices going up and the consumer
Of course,
having
yeah,
the loss.
Yeah.
Even an investor having the
I
loss.
completely
We want that space.
I don't want to have only MacBooks to buy. I want you to buy Windows laptops.
Exactly,
That.
exactly. It's a beautiful
And that is
time.
why your MacBook runs for 8 hours on one charge these days.
And
Thanks to
that's
ARM,
why now we're seeing that.
and
Yeah.
which is why everything is going to move to ARM.
Absolutely.
Anyway,
Absolutely.
do you have any thoughts on RISC-V? How does compete with ARM? Like, is it an actual risk to ARM at all?
I'm not the right person to comment too much on that. I don't think it's a risk to ARM right now. I think a lot of people are trying, of course, as humans do, to innovate on what's already existing to find their own niche. And maybe, but I'm not knowledgeable enough in that space to be able to comment. But on the ARM architecture side, I think if you see what x86 did for the last 20 years, you can see how hard it is for industries like that, all this value chain to pivot. So I think ARM has a head start, and by head start, it's been there for a long time, but the traction is there. So my money is there now. I think the industry is going to be pivoting towards that. And once you put the capital behind the machinery, the software, the design, it's going to be hard, but not impossible. If they show their mettle right now, maybe.
Will x86 survive at all?
For now,
Maybe
yes,
so.
because a lot of the legacy stuff will still live on, but I think sooner or later it's all going to be on. It's no way to hide from it. The power draw, it's going to be all on.
And I know we discussed this earlier. You mentioned you can't talk about gate all around, but can you help us understand what that means? What does gate all around mean?
Yeah, on a high level, I can talk about it. So essentially, the transition it's all transistor nomenclature. So you started off with the big micron level transistors. They were all what we call planar. So for the viewer, it's basically a 2D. If I'm looking at the transistor, I just see a simple trench, a simple source, a simple drain, and a channel. As we scale, we created FinFET, three-dimensional structures, and we embedded the gates around in a very smart three-dimensional way. Gate all around is re-envisioning the transistor with having multiple source trains within a gate and then multiple gates within a space. It's very hard to visualize. I encourage users to go look at some of the YouTube videos around gate all around where they draw using Synopsys' software. They'll show in a 3D space how that GAA looks like, what gate all around looks like. It's really, really difficult. The value problem that we're trying to solve in this industry, which I cannot really talk about much, once we solve that, it's already in existence, but once we solve that for high yield on the same level that the current technologies of 28, 14, 10, and 7 do, then we're beginning to unlock cheaper costs for the consumer, which I care about a lot. I don't want to be playing thousands of dollars for a phone in the future, which were already there. Phones are costing $2,000 now. I don't want that. That's coming from the complexity of the processor, complexity of the manufacturing, and they're forwarding the cost to you.
Yeah, makes sense.
And I think as soon as we figure out a lot of these HVPs or high value problems in the manufacturing space, companies like Applied, companies like TSMC will be in a better space. And that's what I'm hopeful for.
Awesome. Last question for you. So you told me to buy Nvidia in 2016 when we first met.
Yeah.
And I bought it. I sold it because I'm not into gaming. But then I bought it again because I realized Nvidia is doing well in everything. So it's kind of like eventually start doing well. What do you think about Nvidia today? Like I'm not going to discuss Nvidia offline quite a bit. But what are your thoughts on Nvidia?
Nvidia has been a company that I've idolized for a very long time, including the CEO. It's rare to find a founder CEO now that has the passion and drive to do what they do. And it's very hard what they do. They literally invented a new space from scratch. And to be honest, in 2016, I would lie to you and say, yes, I predicted this movement.
Oh no, you told me it was gaming. You liked it for gaming back then, yeah.
And then back then, the hint of AI, the promise of AI seemed very, very real. I didn't understand crypto in its explosion at that time. I knew what it is, but I didn't expect the GPUs would play a big role. But AI was definitely in the horizon, and we understood that this will become a factor, but we just didn't know how much. And I think on the GPU side, I've been a nerd all my life. So like, my dream was to build my PC when I got all the money from work, and the GPU was the central element. I didn't care about anything else but the GPU. And since 2016, I've been buying in, and it's never let me down. I still think now, still a lot of headroom, because fundamentally they've been investing in AI for 15 years. People have to understand the 15-year investment, especially in the manufacturing, the IP side, the technology side, that is a long
came out in 2007.
time. Yeah, long time for people to catch up. There are confidence. I believe in Lisa Su. She is an excellent leader in AMD. And I think the game will come to them very quickly, but I think they still have a leg up because the software they built around their AI is not just the fundamental foundry stuff and the chip stuff. They've built ecosystems around it that right now, from my friends that work in that space, they save the engineers time, they save the developer time, the data analysts have saved time. So I think they've built that buffer. So I think right now, still, I personally, and I'm not an advisor in any note, but I'm still an investor and a very big one. I really believe in it.
The final last question. To me, the holy trinity of semiconductor industry is TSMC, Nvidia, and ASML. Do you agree with that? Would you add another company to that? Would you take something out?
I can't agree with that because if you look at it from an investor standpoint, yeah, I totally agree with you. Those are the companies that are absolutely outperforming everyone, which in your side of the world, absolutely. But from my vantage,
it's not so much about outperforming. They all have something that's extremely unique and like
correct,
which nobody else has in the industry.
Yeah, but that's diminishing companies that are also working on the hardware side that don't get that light. So yes, I would say that Trinity has been like kind of coveted by a lot of people. But from the engineering side, it's impossible for me to say that because, for instance, without Applied, none of these people would exist. None of them.
Of course, yeah.
And it's really underrated what companies like mine do. And by no means am I trying to be biased, of course, but the amount of work I have to do to make a tool like that work on the level that they want it is blood, sweat, and absolutely a lot of tears. So by that standpoint, I have to not agree, but I think those companies that you called out are the unicorns. They are the people we all look up to, and they are our customers. So eventually they feed us and feed you. So we need to work towards their goals and aspirations. But the end game, never ever forget, the consumer is the person dictating the entire stream. Your workload, your time to design this video, edit this video, release it to the world, people watching it, that's what drives us all. So I would say that is the one and only Trinity, is the consumer. And we all work for that consumer. So yeah, that's what I would say.
Well, thank you for your tears and your hard work. And thank you for making time for this, man. This was great.
No, absolutely. Anytime. I'm happy to talk about it.
Hug it I think I pressed record. Let me check if I pressed record everywhere. Let me turn this off.
People are calling.
Dang it. Recording, yes. How do I start?
No way, dude.